Every cross-connection poses a different risk based on the probability of the occurrence of the following: a physical connection between the potable water supply and a hazardous substance, the occurrence of backflow conditions, back pressure, or back siphonage, the total failure of the backflow preventer used to isolate the cross-connection, and the probability that a non-potable substance is present. Properly selecting a backflow preventer depends on an accurate assessment of the risk of contamination of a potable water supply. The degree of hazard, high to low, must also be identified. Installation criteria and hydraulic conditions must be evaluated by a trained professional before a backflow preventer can be installed. Several organizations set and recommend certain types of methodologies, devices, and assemblies of backflow preventers. Many devices can prevent backflow of contaminants into a water system. The degree of hazard generally determines which of the basic devices that should be used. The most common devices include an air gap, a reduced pressure principal backflow prevention assembly, abbreviated as RP, double check valve backflow prevention assembly, or DCVA, and pressure vacuum breakers, abbreviated as PVB. Air gap. Air gap is the most effective way to prevent a cross-connection by a separation between a potable water source and a non-potable source because air disrupts the flow. An air gap is not a device. Rather, it is simply physical space. An air gap may look like this, or this. The most common place you see an air gap is in a kitchen and bathroom. There should always be space between the water source and the flood level rim of the receiving vessel. Reduced pressure principal assembly. Reduced pressure principal backflow preventers, or RP, provide maximum protection against back pressure and back siphonage conditions. This device consists of two spring-loaded check valves with a pressure differential relief valve located between the checks. Water flows into the first check valve. As the first check opens, it fills the reduced pressure zone and the top of the diaphragm at the relief valve at a minimum of 2 psig, 13.8 kPa gauge. If there is a back pressure, backflow, or back siphonage, both checks will close and the relief valve will open, venting water to the atmosphere. RP is an assembly designed for both high and low hazard applications. RPs must not be installed in pits where the relief valve could become submerged. RPs should not be installed where platforms, ladders, or lifts are required for access. Double check valve assembly. This assembly consists of two internally loaded independently operating check valves installed as an assembly between two resilient seated shutoff valves and four properly located test cocks. In normal operation, the check valves will open to allow water to pass through. In a back pressure situation, the second check should close. If it doesn't seal properly, the first check will back up the second. The DCVA is only used for low hazard applications. Pressure vacuum breaker. This is a device designed to prevent water from being drawn back into a water supply when the line is closed. The PVB has an internally loaded check valve and an air inlet valve located on the discharge side of the check valve. The PVB is only designed to prevent back siphonage and can be used for internal protection, but not against back pressure. It should be installed where it can be easily field tested and maintained. Assemblies protecting the public water distribution system often have different needs than plumbing code fixture and appliance protection provides. It's more than placing a valve in the pipe. There are detection devices that monitor DCs and RPs that usually include a meter and bypass line for monitoring water loss, but more importantly, safety for fire protection. A double check detector assembly, DCDA, is primarily utilized in fire line installations. Its purpose is to protect the potable water supply line from possible contamination or pollution from the fire system. The reduced pressure detector assembly, RPDA, is typically only used on fire line applications. However, this assembly is intended to protect the potable water supply from fire sprinkler systems that contain chemical additives or can be connected to an auxiliary non-potable water source. There are operational limitations of certain assemblies, and they may not function correctly under certain circumstances. For example, assemblies may discharge more water than building drains are designed to carry, creating flooding issues. The assembly discharge may not be potable water or could be toxic or harmful to sanitary sewer systems. Assemblies may not be submerged. Installers need to avoid vaults and enclosures without venting. Likewise, they should not be located near any corrosive or toxic fumes. Also, backflow protection devices must be secured and protected from vandalism, sabotage, and theft. Vandalism and/or sabotage could result from a disgruntled employee or someone not understanding the importance the backflow preventer represents in protecting public health. And due to the materials often used in backflow preventers, they may also be seen as a target for scrap metal. Plumbers and specialists who install backflow prevention devices should be aware of several factors. Service connectors, for example, will require an expansion tank for thermal expansion. Additionally, backflow preventers produce a system pressure loss, and installers should be mindful of plumbing codes and the minimum pressure of 15 psi. Service connection assemblies do not protect the building occupants from internal cross connections. Cross-connection control and backflow prevention program requirements differ by county, parish, region, state, and province. You should check to see who sets the requirements in your area. If you have any further questions regarding backflow prevention or cross-connection control, consult the following American Water Works Association materials for more information.